Yeah, hi everyone. So we'll get started with continuation from, the previous session. So we discussed in our previous session on like what is dimension, then we discussed what is fact, what is a dimension table, and then what is a fact table. So before we, start with schema, because schema, any entry you go right on the data warehousing. So this is a mandatory question they'll ask you is schema, types of schema, or like different questions. That stuff we'll be seeing it today. So before we get started with schema, so if you have any questions in the previous session, you can just ask me. I'll just clarify it before we get started with the today's session. So anyone, any questions from previous class? Hello guys, everyone, right? So any questions? Okay, so everyone good with like what is dimension, and then what is a fact, and then what is a dimension table, and then what a fact table contains. Fine, perfect. So now what we'll do basically is we'll get started with the, yeah, so as you know those concepts, right? So today we'll just focus on schema. Yeah, so basically schema is a collection of objects. Schema is objects. So objects, basically when we say objects, right? So whatever tables we have, right? Say for example we have say dimension tables, and then we have fact tables, right? So this particular tables here, so you are going to combine, so that particular thing is called schema. But how we combine and based on like how we define the relationship between them, schemas are classified into different types. So that different types we'll see, but first let's try to understand, so what is this particular collections of objects, right? So first we'll just try to understand the schema stuff. So for which, if you look at this particular table here, so these are all tables which belongs to a retail domain. Say for an example, when you have a retail, right, you a retail business, and that particular retail, so you have one of a table which stores your store related details like ID, what is the store name, and what is that particular store or like anything. So those particular stores will present in multiple locations. So for each of these particular locations have that particular store ID, and in each store, right, so there will be a responsible person. I put like store manager, store like manager contact, store contact number, and so on. So in this way I'll have various details stored under the store. and in each of this particular store, right, I'll have various items here. So I have what different subcategories I have in my particular store, and apart from subcategories going to same, and what are the different items I do have under it. So apart from that, so what is that particular item description? So all that particular product information I'm going to load in this particular table. And say for example, so when I have products in my store, so obviously customer comes in to buy that particular products. So I'm maintaining that particular customer details. So he's coming into my store, what is his particular name, what is his particular mobile number, what is his email in order to send a promotional emails and so on. So I capture that particular information in the customer table. And apart from that, so I do have that information, okay, on which day is buying, which week is buying, which month, which quarter, which year, right? So that all information I'm maintaining in my LU underscore, say for example, time related table. So, and when he buy certain item, so out of that particular item, so what is the sales I'm getting, and then what is the profit I'm getting. So that information I'm going to store in this particular table. So in this way, say for example, in your project, you do have 5 different tables, like one customer, the other one store, sales, product, and then the time. So these are the 5 different tables assume you have in your project. So you went into some company, you joined some project, and in that particular project for a minute, assume that these 5 tables are given to you. And basically, after giving this particular 5 tables, then basically the client or a business user now feel all of you are a MicroStrategy developers, each one of you individually, and you have been given this particular 5 tables. These 5 tables are present in your project, and for a minute assume I am a business user. So I, as a business user, what I am doing basically is I asked you to pull one report. So what does that mean is, say for example, say I want to find a list of customers. I want to find out list of customers who bought, say, iPhone 7. Say for example, I have a 7 plus in plan, so which is, I mean, already came in, but like say for example, in a few weeks time, I'm just launching a new model for which all the persons who have purchased previously, right? I want to just send some particular alert or some promotional message to all that particular customers. So on that lines, I want to find out list of customers who bought iPhone 7 assume for a minute. So where that particular iPhone will be present means it will be present here in the item ID, the model number, item, I mean iPhone 7, iPhone 6, iPhone 6s, iPhone 7. Alright, so all that particular information here, like that mobiles, right, mobiles, and then we had laptops, all these things under subcategory. If you look at previous example we have seen, and then under the category ID, so we have seen that books, electronics, a higher level is this one. So that iPhone 7 is present here, and I want customer and his name, his contact number, and his email ID. So assume in this particular table you have the email IDs as well. So I want to send them email as well as I want to send them a text message. So what I want basically is I want the customer's email ID and their mobile. So that is a key thing for me. So rest all is fine. So I don't require that. So what is that details I require? Customer name, customer email ID, of the persons who bought iPhone 7. So that is my requirement. So in order to achieve that requirement, right? So just tell me with this particular set of tables, whatever I've given you, right? So will you be able to get that result? Or first thing, if yes, fine. If no, then what is the reason? And then if at all I need to get it, then what should I do? So just tell all this particular thing. So first thing, either yes or no. So I want to find list of customers who bought iPhone 7. So you get that information, okay? So 2S. So how about others? So guys, I'm expecting more responses. Okay, 3S. Okay, say for example, no one agrees with me. I say no. So no one tells that no. At least one among you, no one wants to go with no, answer as no. So if you have asked me, I could have said no. Or let me tell you, like no is a correct answer. So no one among you, right? So got it correct, fine. So I'm telling now, no is correct answer. If so, what is the reason? Just tell me what do you feel is the reason why I said no? So the correct answer is no. Okay, so no relation between those tables. Okay, how about others? Still yes or no? No, Ranki, no. Okay, I mean expect fast responses at least for like for every question, right? So we'll have that 5 members, at least 5 members answers it, then only we'll go ahead with the other things. So I got for this 3 things. So first no, no, no. Then any other persons want to say it like we don't get it, no. So I'm waiting of couple of more responses before we get started. Okay, so now no, no, no. Okay, fine. I got 5 responses. Fine. So yeah, just the question is like very simple. Now, very simple. Just try to understand. So whenever you need to get data from more than one table, say for example, you need to get data from 2 tables, or you need to get data from 3 tables, or you need to get data for 4. So in order to get data from like multiple tables, so you need to have a relationship. You need to have a relationship. So in order to fetch data from 2 or more tables, you need to have relationship. So on that particular lines, now, so initially I asked you question, I need to get these details as well as I need to get these details. But in order to get that details between these 2 tables, there is no relationship. So still if you try to pull the data, then it is going to perform a Cartesian join. So what is Cartesian join? Like out of syllabus for now, but for a minute, just try to understand here. So between these 2 tables, if there is any relationship, then only you are going to get data. Then only you are going to get data. So in this case, so LU customer and then LU product. So between these 2 tables, there should be some relationship, and that specific relationship, just try to understand here. So now I can establish a relationship such that, so I can just place my customer ID, come here and then place customer ID here, or else I can place my item ID here. That is, like say basically we said parent-child relationship. So this and this basically we said it is a parent-child relationship. So on that specific lines, right? So now I want to find list of customers who bought iPhone 7, right? So between these two, there is no relationship. But client also, right? Business user also want a list of customers who bought iPhone 7 from specific store only. I don't want in all my stores. I want only in a specific store. So in that particular case, the requirement now, customers I need to get. I need to get the item from a specific store. I need to come here. And then on this particular store, on a particular day, I don't want on all my days. So I want only my sales on Thanksgiving, or else I want only my sales which was on 26 January when I have offered different offers, right, in my Reliance store. So I want to find list of customers who bought iPhone 7 in Reliance Digital Amirpet on 26 January 2017. So this is my requirement. In order to get data for that particular requirement, I need to get data from all these particular 4 tables which are listed here. So it has to bring data from customer, product, time, and then the store table. So now between these 4 tables, there is no relationship. There is no relationship. So in order to bring data from all these things, right, there should be a relationship. So now basically I can just come here and then I can place here my customer ID, come here, place item ID, come here and then place day ID and so on. So basically between these tables, I can establish a parent-child relationship by taking, say for example, customer ID and then I place here customer ID and so on. And then I take item ID, place somewhere table and just I try to relate them. But generally, in case of dimension modeling, so just try to see. So generally when we discussed the differences between OLAP to OLTP, so we discussed that. So in case of OLAP means data warehouse, so we are going to divide the tables based on the subjects, So subjects here basically means customer is one subject. So I have stored all my customer related columns in one table. I have all these particular columns which are related to products. Hence I have stored all that particular product related information in this particular table. So similarly, I have like all that particular columns which are related to time, which I have placed in this particular table. Same the case here, all the particular things stored I have placed under this particular table. So just try to understand here. So this is customer is one subject, product is one subject, time is another subject, store is another subject. So between different subjects, or technically calling, these are called hierarchies. What we call technical elements, hierarchy. So this is customer is one hierarchy, product is one hierarchy, time is another hierarchy, store is another hierarchy, or these are different subjects. So between different subjects, you should not establish parent-child relationship. You should not establish parent-child relationship or primary key and foreign keys. So between customer and product, these two are different subjects. Same the case with store and product, store and customer. Same like with time, product, or subjects. Hence, we should not establish any parent-child. Not place my customer ID here or item ID in other table to relate them. So instead, in dimension modeling, between different hierarchies or between different subjects, how the relationship is established means, so in between. So what we do basically is, we'll have a table which contains facts like profit, revenue, unit price, discount, all those things. And in order to get the first requirement, so what I am doing is, I'm putting customer ID, one thing, and apart from customer ID, so what I am doing basically is, I'm just trying to place my, so what I am doing is, I have placed customer and then I have placed item ID. So this between table, right? So you see some table in between, right? So these are the facts, sales and profit. Item ID and customer ID are the dimension keys. Customer ID is the key column of this table. Item ID is the key column of this table. So which table is this? Is this a dimension table or is this a fact table? So which table is that?
Fact table.
So it is a fact table. So between this dimension table, so this table there is a relationship. And on a similar lines, so if you just look at this one, so I do have a similar relationship from item table to this specific table. So now if you look at this one, from customer table to this particular table, which is your fact table, I just provide the name as f underscore sales table. So I have a fact table. So in this particular fact table, so what I am doing basically is I am storing the dimension keys, and then I am storing how my business is running. These are the key things, profit. These are my facts. And apart from this, between these two tables, in order to establish relationship, so what we are doing is placing two tables key columns. That tables key columns, or in other words we say dimension keys. Item ID is a dimension key, customer ID is a dimension key. So we are placing the dimension keys where means in the fact table, So once you place these two dimension keys, so what happens basically in the dimension modeling is it is going to establish a relationship between customer table to product table. So between customer table to product table, you have a fact table which is establishing the relationship by containing that two dimension keys. Say now you want to get that result, list of customers who want iPhone 7. So that can be possible. So what it does is, so first it comes to this table. In this particular tables, it takes that item ID. So means for your iPhone 7, it has some model number assume, some item ID. So it takes that item ID, it comes here and it checks for all the customer IDs, who bought that iPhone 7. So then from that particular ID, it takes that particular ID. From that particular ID, it is going to pull corresponding mobile number and email ID. So that is how it gets it. So in this particular case, whenever you are going to fetch list of customers who bought iPhone 7, first it goes to this table. It gets that iPhone 7 information. Using this particular key, it is going to find out the IDs of the customer. Then it goes to this table, and from this table it is going to pull mobile and email ID. So is that fine, guys? Now these three tables, customer, sales, and then product. So I say these three tables are related to each other. So any questions on anyone? So anyone has any questions related to it? Are you good with this particular relationship? Customer table is related to fact table. From fact table, you have relationship to product table. Okay. Similarly, now I want to find out in a specific store in Reliance Digital, or else I want to find out in Big C. Right. I want to find out in Universal and so on. So in order to get that information, is that possible or not possible with current design? So I want to find out list of customers who bought iPhone 7 in Big C. Is that possible or not possible? No. So because there is no relationship between them. So what should I do in order to get that data? So I need to get that data as well, because my end user will ask that data, get this particular list of customers who took this one from so and so store. Then what should I do basically? What is the change? In fact table, add store. Yeah, add the store. Instead of store, just we need to add that key column in that one. So I'm just, what I'm doing is, so I'm just adding the store ID. So once I have the store ID, so this fact table is going to now establish a relationship here as well. So now what it does basically is, it is going to establish the relationship between these two tables as well, store table to fact table. And similarly, you want on a specific day assume. So you want on a specific day. So for which you need to have even that key also. So once you have that particular key, so it is going to establish the relationship between this particular fact table to your timetable. So once you have this relationship, right, so you can bring any combination. You want to find out list of customers who came on a specific day from here to here. here to here. So any particular direction you can get the data, because now all these particular tables are related to one another. And then say for example, now in other case what I want is, say I want to find out, say my day wise sales, means whatever the item it is. So I want to find out on each day what is the sales, or like what is the sales for this week, because end user doesn't bother which item, which product until his business goes well, right? So he just want to see in last 1 week what is my sales, last 1 week what is my sales. So for last 1 week what is my sales means which two tables should be there, LU underscore timetable and then a F underscore sales. So if you look at this one, sales is maintained at which level? Sales is maintained at the day level. So load the sales information at the day level. So once you load the day level, so what it does is it collects the sales information. First the control package, it is going to contain the sales information. It takes that sales information. Using this day ID, it goes to this table and then it gets the detail at the week level. So it is going to add 7 days in order to get the data for that particular week ID. Similarly, they want for month ID, they can get it for quarter, for year and so on. So whenever you use any fact on the report or any metric on the report, first the control comes to fact table. From the fact table it takes a fact at the key level, then it goes to its corresponding parent table and get the data at the higher levels. Get the data at the higher. So this is how it is going to work. So we'll take a lot of examples and get more details on it. But primarily now everyone clear on this particular relationship, and everyone just understood one thing is, so you'll have dimension tables, fine, which stores the textual value which describes about your business. But again, which is going to play the key role basically is your metrics or facts are going to play the key role for your business. And generally, in order to have a relationship between different dimension tables, what you need to have basically is you need to have the dimension keys in the fact table. You need to have the dimension keys in the fact table. So the important purpose of fact tables is to establish relationship between different dimension tables. So if you look at here, 4 dimension tables are related using this table. So in real time, you may have one fact table which may establish relation for 20 tables as well. So will be present in the fact table. So generally, ideally, you will have minimum 7-8 tables related to one fact table on an average. 7 to 8 fact tables related to one fact tables on an average. So everyone, right? So just remember, like you'll have a fact table, and that particular fact table will be surrounded by different dimension tables. Will be surrounded by a different dimension tables. And what fact table contains, we have discussed. But the important point about fact table you need to understand is fact tables are used to establish relationship between different fact tables. Fact tables are used to establish relationships between different fact tables. So everyone clear till this point, or any question before we get further? Fine. Okay. Now basically, now just try to focus here, guys. Now, very simple thing is, okay, right. So you have, this particular fact table and this particular fact table, right? So you'll have, what is a schema basically means, just try to see. So you have, different tables, table 1, table 2, table 3, table 4, and then say for example, table 4 and then say table 5 and so on. So when you have different tables, right? So the relationship, what is schema means? Schema is a collection of tables. Like say for example, so these are the tables. like this is one table and there's another table, and or are like different tables here. So this is one table and you have one more table here, and then say you have one more table here, and so on. So you have different tables here, and this particular tables, right, when you group together at one place, right, then it is called as a schema. But again in schema, right, basically there are different types basically. So we'll just come to there. So basically I'm just for a minute, just give a minute. Okay, so now what is this particular symbol looks like basically? So what is the symbol, this particular symbol, right, implies? Okay, star shaped schema. Okay, fine. So yeah, perfect. Like whatever Ranjit given input, right? So yeah, good. So basically, like if you relate a tables like this as in one fact table. If you look at this table, you'll have one centralized fact table, and this fact table is surrounded by customer, like one particular direction, customer, store, time, product, and so on, right? So when you have a relationship established like this, then it is called as a star schema. Then it is called as a star schema. So what is a star schema basically is? So I mean basically I said, right, so schema means a collection of tables, and this collection of tables has to be related. In order to get data, it has to be related, and the relationship is done by using two types of schema. So one schema is called star schema, the other one is called as a snowflake schema. So there are two types of schemas. One is star schema, the other one is a snowflake schema. So what is star schema means? If you have a centralized fact table, means in between you have a fact table which is surrounded by different dimension tables. So in this case, time, product, customer, store, right? So when a fact table is surrounded by different dimension tables, then it is called as star schema. It is called as star schema. So clear everyone? So what is the definition of star schema means? If you have a fact table surrounded by dimension tables, if you have a fact table surrounded by dimension tables, or this fact table generally we refer as a centralized fact table. So if you have a centralized fact table surrounded by multiple dimension tables, then it is called as a star schema. Clear everyone, or any questions? I'm saying this concept is very important for an interview. What is star schema? What is snowflake schema? So on the definition of star schema, is that clear? So if you have a centralized fact table surrounded by multiple dimension tables, then it is a star schema. Okay, fine, good. So now the second point, like I'm asking you a question, so just I'm expecting an answer from you. So looking at this table, just tell me whether this table is a normalized table or whether it is a denormalized table. We have spent enough time in our previous session. So looking at this table, we took the same example as well. So just tell me normalized table or whether it is a denormalized table. So majority with normalized. From 5 answers, I could see 4 as normalized and then couple of them as denormalized. Okay guys, like going back to, I mean, forget about this table. So when we say denormalize, right? So what is it? So looking at a table, how we can say normalized or denormalized? Okay, duplicates. A good Tarun. So is this particular table is going to contain lot of duplicates or no? Repeated data or duplicates, fine. So is this particular thing going to contain lot of duplicates or it contains a unique data? Description data is repeated, fine. So here lot of duplicate unique data. So there won't be unique data here. So if you remember the same table we have looked like, say for example, if you write in other way like columns, right? I've written one by other. So if you write like this, category, ID, and then say for example, category description, and then you write subcategory ID, and then you write subcategory description. If you remember in our previous class, this is the same example we took, basically item ID, and then say for example, item description. So when you have this particular all columns present, right? So you have to repeat 0, 1, electronics and so on. So this is what we discussed in our previous session. Yes or no? So here there will be a lot of duplicates. And this particular table, whatever you say here, right? So this table is a denormalized table, not normalized. Normalized means, like I'll ask you, because that is our next type of schema. So for a minute, so everyone agree this is a denormalized table, and in case of star schema, we'll have the dimension tables as denormalized, means we'll have lot of duplicates present in the dimension table. Same the case here. So for day, right, week has to repeat lot of times, month has to repeat, quarter has to repeat, year has to repeat. So this particular timetable, whatever table you have like LU underscore time, right? So this particular table also contains lot of duplicates for year, quarter, month, week. So this is also a denormalized table, as in it is containing lot of duplicates. So what the point here is, in case of star schema, in the star schema, you will have lot of dimension tables as denormalized, or in other words, the dimension table contains lot of duplicate values. The dimension table contains lot of duplicate values. So remember that point. Fine. So now what is happening basically here is, as there is lot of duplicates from here to here, so when I try to get the information, like item wise sales information, so I need to hit two tables. So one is product table, the other one is the sales table. So between these two tables, I need to get the data. Fine. So first thing, I need to get item wise sales information. But in order to get data at subcategory, I have to do what? A group of items. If I combine it, then I get the data at the subcategory. Like all mobiles I combine, then I get the summation at the mobile level. And then I want at electronics level. If I group certain subcategories, then I will get data at the category level. Then I will get the data at the category level. So this is how it goes. Group of items, subcategory. Group of subcategories, it is going to bring the category wise information. My client or my business user, for most of the cases, he is running this report, category wise sales report, category wise sales report, for which what is happening is, as my particular sales are maintained at item level, from here the control is coming to this table, it is grouping items in order to get subcategory, then it has to group certain subcategories in order to get category. As this table has lot of duplicates or repetitive data, the time it is taking for that aggregation is more, or it is high, for which rate the report is taking more time to execute. So whenever the client is running category wise sales report, it is taking say 2 minutes, but the client wants it very fast. He wants to get it fast. So, but we have seen this table, the size of this table is very huge. So when you hit this table, obviously there is a chance of taking more time, but the client is not happy. So what is that alternate you can think of? So what I am telling is here, as you have lot of duplicate values, it is taking more time. So what can be the possible reason we can think of in order to improve the performance? Making it normalized. Okay, so fine, Tarun, whatever you said is perfect. So making it normalized. So how do you normalize? Now the question here is, so you said it is normalized, fine, perfect. So now this table, what should I do? Yeah, cluster index now, like indexes is out of our portion, Ranjit. So I'm agreeing with Tarun answer. So Tarun, like you said, you have to normalize it. So normalization means what? So when I say I have to normalize this table, then what does that it mean? So breaking the table. So instead of one big table, you need to break that into category as separate table, subcategory as separate table, item as separate table, and then you need to have a relationship between them. So create a separate category, subcategory, and item table. So the same thing basically, I've just done that. So I'll show you. So this for a star schema. I've just provided a rough thing till now. So now on a similar lines, if you look at this specific thing, okay, so now if you look at this specific thing here, right? So this is what like normalization means. That table was denormalized. So in order to normalize, what I have done is I maintained my category ID, category description as separate table, subcategory ID, subcategory description separate table, item ID, item description separate table, and I need to have a relationship between all these three tables. Hence, if you look at this one, so this subcategory ID here, then category ID here. So once I have category ID here, so it established relationship between these two tables. And once you have this one, subcategory ID here, it established relationship between item to subcategory. And between this table to this table, direct relationship. Subcategory to category also there is direct relationship. But from item to category also there is relationship. What is that relationship means? It has an indirect relationship using subcategory ID, or else in other words, let me tell you, sales table to item table direct relationship. Sales table to subcategory table. Is there relationship means? Yes, there is relationship, but not direct. First from here, it goes to item, item to subcategory it relates. From fact table, do you have any relationship between category table means? Yes, it has. From here, the control goes to here, then here, and then category table. So now all these four tables are either directly or indirectly related to each other. So when it is taking more time, then what is happening basically is you are normalizing it. So clear on normalization, right guys? Still last time also we have seen the definition and we have seen example, but still today at least first four members said it as opposite. Instead of denormalized, you said normalized. But now is it clear? Of a big table duplicates denormalized. Breaking that table, establishing the relationship between them, then it is called as a normalization. Right. So now this is a normalized, fine, perfect. So right, this particular type of schema, whatever you're seeing here, right? So in which you have normalized a dimension table. So what is it basically means? It is a Snowflake schema. So there are two types of schemas primarily we use in the dimension modeling. So one is a star schema, the other one is a Snowflake schema. Star schema we have already seen it. So in case of star schema, we'll have one centralized fact table surrounded by dimension tables, and the dimension tables are denormalized. Whereas in case of Snowflake schema can also be called as extended star schema. Snowflake means extended star schema. Either name is fine. So extended star schema means, so here what happens in case of Snowflake means you are going to normalize the dimension tables. You are going to normalize the dimension tables. So the product one you have normalized it. Similarly, you can normalize the day table as well. For day you can maintain separate table. For week you can maintain separate table. For month you can maintain separate table. For quarter you can maintain separate table. For year you can maintain separate table. So in this way, in the time also you can maintain 5 different tables, or you can normalize that LU underscore time table. You can normalize the LU underscore time table. So I mean, if someone asks you Snowflake, very simple. Snowflake is an extended star schema in which we'll normalize the dimension tables. We'll normalize the dimension tables. So as soon as you ask it, then the interview will ask you what is normalization. Then you should be in a position to answer that particular question. What is normalization? So definitions are simple basically. What is star schema? What is Snowflake schema? I mean, still I have to receive a lot of persons email IDs and so on, so hence I'm not sending it until I get everyone. I create a group, I don't forward it, so hopefully by today or tomorrow, just people who have missed out, just send me so I can share it all together instead of resending it multiple times the material. So I'll give this material, the definition, you can see it here. So again, so if someone asks you which schema is denormalized, you should know that, okay, star schema is denormalized. Which schema is normalized? Snowflake schema is normalized. So these things you should be perfect. Someone asks you in an interview. Fine. Now, basically, now like some advanced things or like some extension to it, like apart from definition. So a lot of people teach this definition, but like we need to understand a bit more. So basically looking at this particular design here or looking at the tables listed here, now the question here is, say for example, now this particular thing, so just try to understand here. Guys, everyone try to focus and try to understand my question. So I'm just removed that one. Now I have item table, subcategory and category table. So in this particular fact table, is that fine if I store item ID, or instead of item ID, can I have category ID as well or no? So just try to focus, try to think and tell me. Nothing is, I mean, you need to answer fast. The question here is, earlier I have item ID here. So instead of item ID, is that fine if I store category ID in my fact table? Okay, one no. It is of no use. No, okay. Fine. So, I mean, for a minute, let's try to analyze and then try to get the solution here now. So whether I have to store that or whether I have to store this, just try to focus here now. Basically, now the category ID is a question for us, right? So let's try to take an example and then from there let's try to understand it. So basically I have my fact table. So my fact table is containing, assume 2 columns only. Say for example day underscore ID, and then say for example category underscore ID, and then say for example sales. So day is, say for example 2nd February, and then for say for example electronics, the sales happened is, say for example $5,000. Same on 2nd February, then under books category, then basically I had, say for example $1,000, and then say same thing on the 2nd February, right? For say for example, music category, say I had $500. Similarly, 01 February, same thing, electronics, 3000 US dollars. And then 1st February, say under books, I had $400. Same 1st February. Then for music, I had $500. Okay, this is my table assume for a minute. And for a minute, like let's take this one as an example. So I have, for example, I'm taking, I have say for example, 3 categories here. So total number of categories in my project is 3. And what I'm telling, so this is not exact. So under each category, there are 10 subcategories. So under each category, there are 10 subcategories. And then similarly, what I'm telling is under each category, there are 100 items. So under books, 100 books. 100 under like electronics, all electronics, 100 items, and so on. Okay, fine. And this is my fact table. So this is my F underscore sales fact table. So whatever we have, that table is having like this data assume, because we are storing data at day level, we are storing data at category level, and then we are storing the sales information. So that is how I have listed here. Okay. So in this particular table, I am storing 0 to this one. Okay, fine. So this report I have given to you. You are for a business user assume. So I am telling you are my business user, and as a business user I have given this report, and this report is perfect. It is very accurate. Fine, good. But now the question here is, the end user came back and then asked me, so I want to get my information, say for example, I need to get a report like this, day wise item sales. So can I say simple thing like 02nd February, say item X, say for example 5000 divided by 100, total I have 100, right? So can I tell $50? So what I'm doing is I'm just dividing category value. I have under one category 100 items, right? I'm just dividing by 100. So is this calculation correct or it is incorrect? So under item wise sales, if someone asks me, can I do this value divided by 100 to tell that item X, item Y, item Z, all items got $50. That means that same thing, right? So I have total 100 items and I am telling for my category I got 5000. So I am telling for my item 1 it is $50, item 2 $50, item 3 item 100, till item 100 I am telling it is $50. Is that correct or is it incorrect?
Incorrect.
So it is incorrect. So that won't be the case. Yes or no? So it is an incorrect. Fine. Perfect. So basically for that reason, right? So just try to understand here. Now when you place category, the problem here is you cannot report at the lowest level. When you report at category level, you get the data correctly. But when you try to report at the highest level, sorry, at the lowest level like subcategory level or item level, you get the data incorrectly. So one thing, category level sales you get perfect. But when you try to see data at subcategory or item level, it is going to come incorrect. So on that lines, right, so on that specific lines basically, so just try to remember guys, always in your fact table, these are your facts and you are going to store the lowest level dimension keys. The lowest level dimension keys means from this particular thing, item is the lowest level. So hence you are going to store item level information. And second thing, now consider about this table for a minute. I'm just not breaking it, but for a minute assume like this is also normalized. So once I normalize it, I have just try to understand day table separate, week table separate, month table separate, quarter table separate, year table separate. So total under LU underscore time, I have 5 different tables: day, week, month, quarter, and then year. So 5 different tables I have, and here I have 3 different tables here I have, and this is my F underscore sales fact table. Fine. So now just for a minute try to understand my question guys. So under LU time and then now under basically the product one, just try to focus here now. So this is very important concept, very much required for our MSTR skills. So this is a last or like advanced concept. So just try to focus, very simple. So assume for a minute you have like this one. So you have a tables like day, and similarly you have week, you have month, and so on basically assume. So the question here is, now just try to focus. This is also very frequently asked interview question, so just try to concentrate here. So you have similar to day table, right? You'll have, say for example, a month table and then an year table. Assume for a minute I'm just providing at least 3 different tables. So from this we can understand, say, one important concept. Let it be here. So you have say for example one more table. So one is a table which has at the month level information. So other table has, say for example, month underscore ID, and then say for example month underscore description. So this is one table, and then so between day table to month table there should be some relationship, right? So hence assume in this particular table so we have a day ID and then month ID. Fine. So let me ask a question. So meanwhile I'll just do it. So basically assume for a minute here you have a day table and then you have a month table as well. So now the question here is, so I want to fetch data, just try to understand here. So I'll give, I mean concentrate on the tables. Now I'll give couple of scenarios basically, and then based on that I want you basically to tell me which particular report. I'll give some sample reports, and then basically I want you to tell me which report is going to run faster, which report is going to run faster. So based on that, like, you will just understand when we start with reporting, okay, this is how it is going to work, right? For which whatever assignment we do for next 15 minutes, right? So I want inputs from every one of you. So I'll just, explain you the question till 10:45 and then till 11, right? So basically you can just provide your inputs for me. So I have here day underscore ID, and then in order to have relationship between month table to this, then I have like this, and then basically here I have year underscore ID, and then for a minute you have one more table wherein the year table also. So this is one table which is, say for example, which is relating month ID from here to this one, or else, okay, for your clarification, so let me have that diagram as well. So between these two there is a relationship, and similarly, right, so I do have, say for example, one more table which is the year table, and that particular year table simply has year ID and then year description, that's it. So this is my another table which is having, say for example, year ID and then, say for example, year date. And between month table to year table, is there any relationship? Means yes. So here you have year ID, here also you will have year ID. So between these tables there is a relationship, right? So using this particular year ID, there is a relationship between them. Fine. So these are my list of tables, assume. So in my time table, all three tables are related, and then I have a day ID here. And similar the case with here. So time is a normalized and this is also normalized. So now just try to understand here. So I have a report basically. Now everyone simple: item, subcategory, category, day, month, year, and then you have a sales. Total 7 tables. 3 under products, 3 under time, this one. So now I'll give some scenarios for you. Basically, our report one, this report one is basically, say for example, item wise, days, item, day sales it is containing, and then say for example a report 2 which is having, say for example, category, and then category wise month sales, and then I have, say for example, report 3 which is giving me day wise sales, and then I have report 4 wherein I'm getting category wise year, category wise yearly sales, and then I have, say, report 5 which gives me subcategory wise, say for example, yearly sales. So now just think a minute, take your time, but at least again I expect 5 different answers basically before I get started, right? So what is my question here is, out of all these particular reports listed here, report 1, report 2, report 3, report 4, report 5, so which report is going to run faster? Which report is going to run faster? Means first I want sequence. Okay, this report runs faster, then second faster, third faster, fourth, fifth. So I want that sequence 1, 2, 3, 4, 5. So 1 means the faster report. So just give me that sequences. I mean, when you type in, because it will be confusing, like you just type all 5 numbers, then only hit enter. Okay, 1, 4, 1, 2, 3. R4, R5, R2, then 4. 4, 5, 3, 2, 4. Write all 5 numbers in a single thing. Then only probably because you type one, then you enter other, right? So other one. So 1, 3. So report 1 faster, report 3 second faster, report 2. Like how Ranjit has written back to report 4 faster, report 2 second faster, 1, 3, 2, 4, 5. Okay, fine. Basically, alright, fine, fine. Forget about it for a minute. For a minute, let's. I don't see anyone answer written so far is correct. Like let discuss some more things here, and then again I'll take your opinion. Basically, we have still 10 more minutes left. So the question here is, how many less tables are there if whatever like data we are pulling, right, if it contains less tables, then it will be faster. It will be faster. So just try to understand here, guys. So whichever table is having whichever report tries to get data from less tables, then it will be faster. Then it will be faster. So just think on that lines, guys. That's it. So whichever table has less tables, I don't want now one. I want for all now. So only one is correct now. The sequence I want, all the entire sequence. Now you need to think only, okay, report 3 means how many tables? Report 5 means how many tables? Report 1 means how many tables? So whichever report has less tables, then think it will be faster. Three, one. So 3 is correct. And then R1, 3, 1, whatever Tarun said is correct. 3 and 1, number 3, 1. And then 2, category month. So how about R2 and then R5? Okay. So R4 takes lot of tables. R4 should come last basically. So now the question between R2 and then R4, sorry, yeah, R2 and R5. So in case of R2, in case of R5, same number of tables or different tables? So category month sales, let's try to understand category month sales. So in that case, you have here category and here your month. So 1, 2, 3, 4, 5, 6 tables it has to hit. And how about this one? Subcategory year sales. 1, 2, 3, 4, 5, 6, same. So when you have same, let's try to understand. So now for a minute, I'm just removing this one. I'm putting these two together. Fine. So now from this particular 3 numbers, so this particular combination is taking one table to retrieve, sorry, 2 tables. One is fact table, the other one is a day table. And to get data for these tables, item, day, and then sales. So for sales, one table, item, one table, day. So how many tables? 3 tables. And this one is going to take all the tables. So 1, 3, 3. So total it is taking 7 tables. So if you look at this one, so this executes faster, and then R3, then R1, R4. So I mean from this particular 3 list, Fine. I'm just deleting it. Now the question is here. So when I have this combination and when I have this combination. So before you answer this question, right? So you will only tell me what is that answer. So I have a report which has item sales, and then I have another report which has day wise sales report. I have item sales report and then day sales report. So if you look at this one, again look at this one, item sales I want, day sales I want. So in these two reports, which report will run faster? Don't tell me both, because report will run in seconds and so on. From these two reports, which report do you think will run faster? Item wise sales report or day wise sales report? Item. I mean, which one it runs, basically we don't know. I mean, to be open to, I mean, the answer to tell you which one runs faster, right? We don't know. But on what basis we have to see, okay, this report will run faster. So what is that consideration we have to take? So we cannot say item, we cannot say day. It can be either day or it can be item or it can be day, but on what consideration we have to tell, okay, item report will be faster or day report will be faster? Depends on number of items or number of rows. Right, perfect. It depends on the data. It depends on the data. If you look at this, both the scenarios, in the both scenarios, the tables are two only. From this table to this table, from this table to day table. If say for example, items are 1000, are only 500, then day will be more. Or if the days are 5000, items are 400, then this is going to be fast item wise report. So when you have same number of joins or same number of tables, right, from which you need to get data, then what comes into picture basically means the data, the amount of data. Here also, when you have seven tables, we cannot say it depends based on the, it depends based on the data which is present in the tables when we have same set of joins. But now the, I mean, the perfect question here is, so my end user who is at a higher level like CEO, CFO, those guys, right, they don't want to see information at the lowest level. So instead, they want to see always the information at the higher level. Say for example, year-wise category sales. So this is a report which my business user, like a lot of business users, higher management runs this report, because this report contains information at the higher level. Means it is containing data at year, category and sales. So this is the highest level at which they want to see the data. So in order to get this data, year-wise category sales, how many tables we need to use? Or how many tables should be combined to get that data? Year-wise category sales, year is present here, category is present here. Here means 1, 2, 3, 4, 5, 6, 7. So how many tables? We require 7 tables. So will the report will be faster or will the report will be slower? So when we have to bring data from 7 tables, will the report will be slower or faster? The report will be slower, very slower, right? Okay, the client has come to you and then he said, basically what he asked you basically is, okay, I mean when I run this report, it is taking 2 minutes time. So I want it to be, I mean, come very fast, as in it has to load very faster. Alright, then basically what we have to do is, we have to go for some aggregate tables, or we have to create, like instead of this fact table, you have already one fact table which is storing data at this level. You have a data, I mean a fact table which is storing data at day level, and then it is storing data at the item level. But what you can do basically is, you can just come and then basically what you can do basically is, So you can just create one more table. So what is that you can do basically is you can just create one more table, and in this particular table what you can do basically is just try to see. So this is a interview question, so just try to focus. So in case if the performance comes down, right, so how to increase the performance, right? So just try to see, assume this is a fact table. So in this particular fact table what I do is I store category underscore ID, and then I store year underscore ID, and then I store sales. Now apart from one fact table, say in your project you are having two different fact tables. So this is one fact table and above one is another fact table. So now once you have this fact table, from this category, right, from this particular category table to your year table, how the relationship is there basically means a direct relationship, and from year table to your fact table, how the relationship is there, it is a direct relationship. So now the same report, it took 7 tables, it took 7 tables in my earlier example, but now when I say year wise category sales, year wise category sales, by creating new fact table, after creating new fact table, so how many tables it is going to take now in order to bring data for this one? After this table exists, how many tables? 2 or 3? I have to get year description, for which assume, okay, so this is not year, assume like I have mapped it incorrect, so this has to be mapped to year. I need to get year date, then I need to get sales, then I need to get category. So how many tables total? So not 2, it should be 3. So total 3 tables. I need to get category information from here, year date from there, and then the sales from here. So total 3 tables. Agree everyone? So now when they run this initially without creating that fact table, if they run the report, it takes 7 tables, for which it will be slower. But when you try to create this table which is storing your sales at the higher level, so these tables are called aggregated or summarized table. So you create these summarized tables to improve the performance, if there is a degrade in performance when you normalize the tables, so what you do basically is you are going to create that table, that extra aggregated table, so that it is going to improve the performance. It is going to improve the performance. So now assume in your project you have this table and then you have this table as well, two different tables, this one as well as this table. So once you have these two tables, the question that comes is, say which table will be faster. Now very simple question, try to understand here. So day wise item sales report or year wise category sales report. I have two fact tables, not one fact table now, two fact tables. So from this particular two tables, this is one thing. So tell me which table will be faster. So item wise day sales, 3 tables. Category wise yearly sales or year wise category sales, even that also has 3 tables. So which one will be faster? So year table or else this one, which among them that will be faster? The last question for the day, so just category year sales. So how about others? Day wise. Okay, I was expecting this answer, day wise. Then how about others? Year wise report. Okay. Okay, fine. So if you look at this one, let's tell one thing. So here I will have one year column, year underscore ID. Forget about category for a minute. Year ID only. So I'll have like this 2016. What is the total sales? Say for example, some number, some particular dollars. And for same 2016, in order to get data here under the day column, so what you will have? So you'll have starting from 1st January till 31st December, which is say for example 365 values. So which one is better? To get like one single value will be faster, or to get 365 values will be faster? Which will be faster? So in order to read, right, so here you'll have 10 years data, only 10 rows, whereas here 3600 rows, right? So on that particular lines, so that one value which is year, right? So again, when you have same number of tables, then the data comes into picture. So that is where like you need to see, okay, which tables and then how much volume of data, and accordingly you will understand which one will give the better performance. And then yeah, probably that comes yeah based on some experience, but definitely these things you should understand before we, all these are done by your DB team or database team, but again all these are our backend, means all these are going to be present as our backend basically. So we need to have this knowledge. Okay, when I run my this report, so it brings from this table because it is aggregated table, these are detailed table. So these things you need to understand. So one thing is as part of interview, so this very important questions out of today's class, you may expect what is star schema, what is Snowflake schema. Star schema means if you have a centralized fact table surrounded by multiple dimension tables, then it is called star schema. What is Snowflake means? In the Snowflake we are going to normalize the dimension tables. Normalize the dimension tables. What is normalization means? You can tell. This is a splitting of large table into multiple smaller table and establishing relationship between them using parent-child relationship. And apart from that, say they may ask you, say when you normalize a table, there will be lot of indirect joins, means lot of tables will be there in joins. So hence there will be a degrade in the performance. So then how do you improve the performance? How do you improve the performance? Then you need to tell that, so this particular table which is storing your facts, the sales, profit, discount, these are the facts. So this particular facts, when they are stored at the lowest level, when they are stored at the lowest level, then it is called detailed table. It is called detailed table. So now I say this f underscore sales is a detailed table. So now what I am doing is, in order to improve my performance, I am maintaining my sales. This is a fact which I am maintaining at the higher levels, means above item, above day I am maintaining, right? So that particular thing is called as a summarized or aggregated. Say for example, you create a table, you can create one more table which has month ID, subcategory and sales. If you try to pull a report, most of the combination will be month by subcategory sales. You can create one more fact table, sales, month ID, subcategory ID. So that table also is an aggregated table. So if a table other than lower levels, you create any table or any fact table higher than that, then it is called as an aggregate table. So what you need to tell is in star schema, sorry, in Snowflake schema, you said you'll, I mean Snowflake means you normalize table. So when I try to report, right, there will be multiple joins, then there is a degrade in performance, right? Then how do you do it, or how do you improve the performance? So just tell them that we build aggregate tables, or you load facts at a different level so that the number of joins will be decreased and hence the performance will be improved. The performance will be improved. So this is what three possible questions you can expect. So one is what is star schema, the other one is what is Snowflake. They may ask you like this, or they may ask you which schema is normalized. Which schema is normalized? They don't ask anything. So which schema is normalized? Then you need to remember. Or which schema is denormalized? Then you need to remember. So don't confuse. So in case of star schema, big tables you'll have, they're denormalized. And in case of Snowflake, definitely you split multiple joins and so on. So you'll have smaller tables. So in case of Snowflake, it is a normalized. And then they'll ask this question is like in Snowflake, how do you improve performance? So we'll build the aggregate tables to improve the performance. We build the aggregate tables to improve the performance. So these are the 100% expected questions in interview. So you go to any interview, out of 10 interviews, in 9 interviews, I'll challenge that they'll ask this particular 3 to 4 questions, whatever we discussed today. So everyone just refresh this one, and when we start tomorrow, basically we'll be starting with MicroStrategy. So these are the concepts we require. What is dimension? What is fact? What is metric? What is schema? So these are the important concepts which we require to get started with MicroStrategy. So tomorrow I'll be starting with MicroStrategy tool, the basic stuff, 1-2 days, how the tool looks like, how to create a basic report, what are the sections in a report, what is the purpose of it, and so on. It requires 2 to 3 sections in order to understand the interface. So once we understand the interface, the expectation is from Monday, we'll start creating various reports and building different objects like filters, metrics, consolidation, custom group, prompts. So once we start with one object, so initial 2 objects, filters, metrics takes time. Once that is done, seriously, if you are good on filters metric, if you set one long weekend, then we can complete many different objects. But the bottom line, the first 5 hours, like first 2-3 hours of basics that we have to complete by Sunday. So once we complete by Sunday, then from Monday till Friday is a key session, or Monday till Saturday. So once you're comfortable till that point, the course doesn't take much time. You're good till that point, then course completes very faster. So whoever has to start at least with basic, right? So just start from today or tomorrow, so that at least by Monday you need to be good on all these particular basic concepts. So if you don't know, then it will be tough. I mean, the tool is very simple, hardly drag and drop, like from Monday. But again, basically if you don't practice, right, even the simplest tool is going to become harder for you. So fine then, I mean, we have spent like more time than, yeah, whatever we required. So basically we'll just end here, and then tomorrow at same time we'll just get connected to, I mean, start with the MicroStrategy basics concept. Fine then, thanks all. I mean, people over here, good night, and then back over there, right, say have a good day, enjoy your day, bye.